Okay, so hello everyone. Welcome to EEEE Lab number 9. Today we are going to discuss the power measurement using two wattmeter method. So let us start. So first of all, we will see how does a wattmeter look like. So here we have a current coil and a pressure or a voltage coil. Okay, and this is my green color. I have circled it. This is my wattmeter. Okay, now let us learn about now wattmeter is connected to the one side is connected to the mains, that is AC, and the second side we have the load. Okay, and let's check out what is this M, L, C, and V. So ML is the current coil which senses the current, and CV is the voltage coil or a pressure coil which senses a voltage. Now, C is a common point, correct, which is also connected to the mains, and L is connected to the load, and V is connected to the neutral. Okay, this ground is the neutral. In case of a three-phase supply, we have a neutral. So the current coil is connected. If you see carefully, the current coil is connected in the series with the load. Okay, such that the one terminal is connected to the mains and the second terminal is going to the load. Okay, so that's what is written over here. The other terminal is going to the load. Now pressure coil are connected in so this is my pressure coil or a voltage coil. Pressure coils or a voltage coil are connected in parallel with the load. Okay, so you see over here, one terminal is connected to the main and the other terminal is the return part of the neutral of the load. So over here for a voltage coil, one part is connected to the mains over here, C and M, and the other part is connected to the load, which is for the returning part for the load. So that is the neutral basically. So that's how a wattmeter internals will look like. Okay, so let's check it out further. Okay, so before proceeding further, let us understand there are three techniques to measure power in a three-phase circuit. One is the 1 wattmeter method, second is the 2 wattmeter method, and there is another 3 wattmeter method. So in this lab, EEEE lab, we will be discussing explicitly 2 wattmeter method, power measurement using 2 wattmeter method. Okay, and we will be doing it for two loads, that is a star connected load and a delta connected load. So let us check it out. What is star connected and what is delta connected? So you have three phase in your three-phase power supply. You have a R phase, you have a Y phase, and you have a B phase. Okay. If your load, which can be a resistive load or an impedance load, is connected in a star connected fashion. Star connected means like this. So this is my three-phase star connection. So in this case, my phase current and the line current will be same. So please note down, it is a very important point. And my phase current will be equal to line current divided by root 2. Okay. And the total power in this three-phase star connected load will be given by square root of 3 VL into IL into cos phi. Okay, where cos phi is the power factor. Now, if it is a three-phase delta connected load, here I've considered to be a resistive load. It can be a combination of a resistive, capacitive, and an inductive load. Yeah. So here you have R, Y, and B phase. So this is my delta connected load. So in a delta connected load, we have phase current given by IL divided by root 3. Now the line current will be given by root 3 times phase current. That is the same as earlier. And your line current and your phase current will be same. Okay, in a delta connection, your line current and a phase current will be same, but the total power will remain, the formula will remain the same as star connected, which is given by square root of 3 VL IL cos phi. Okay, and we will be considering a balanced load. Balanced load means the following: the phase in a circuit is same and they are separated by 120 degree, as you can see over here clearly. R, Y, and B phase are separated by 120 degree each, so they all are same. Whereas the phase current is also same, but they are separated by 120 degree, and the load is identical. So let's say you have considered a star connected load. So all the values, let's say we have RL, RL, and RL. So all their values are same. So that is what you mean by balanced load. Similarly, if it is a delta connected load, all the values of the components over here, let's say here it is R. So all the values of R are same. So that is the meaning of a balance load. I hope that this point is clear. Okay. Now let us come back to our main point. So we have to do a measurement using a, a 2 wattmeter method. So the circuit diagram is this. So this is the measurement of active power for a star connected load. So you have 2 wattmeters here and here. Their current coil and your voltage coil are connected like this. Okay, we have a R phase, Y phase, and a B phase. So all the phase current will flow, and this is my star connected load. So it's a coil actually. So coil will have a resistance and a small uh, inductance value. So you have RALA, RBLE, RBLB, and RCLC. Basically, if it is a balanced load, then all their values will be same. So that's what the circuit of star connected load for measurement of power using 2 wattmeter method looks like. Okay. So in this circuit, the current coils of the wattmeter 1 and 2 are in series. So you can see over here the current coil will be in series with R and B phase, and the pressure coil will be connected across. So the voltage coils or the pressure coils will be connected in parallel across your RY and BY load. So across your RY and BY load. Remember, in a star connected load, this point, common point, is the neutral. Okay. And yeah, so here the formulas of W1 and W2 are given over here. We will come back to it. And the total power W1 plus W2 will be square root of 3 into VL into IL into cos phi. Okay. So these formulas will come back to it again. Don't worry. Okay. So this circuit we have to simulate in your Proteus. Okay. So let us begin. So I'll keep this circuit like this over here, and I'll open up the Proteus window. Let me keep this over here. Okay. So I'll keep it aside so that I can work on the Proteus window simultaneously. Okay, just wait a sec. I hope this is visible. So let us open Proteus. So this is my Proteus. Let me adjust my screen. I think this is fine. And now let us start. So you go to Proteus 8 demonstration version, and you go select a new project. It will take a half a minute to initialize the project settings. So first we have to measure the active power for a star connected load using 2 wattmeter method. So let us begin. I think it's initializing. So let us wait for, yeah, it's there. So just click on new select next, and click on finish. Okay, once you click on finish, you see the schematic capture has come. Okay, the blue color thing. So inside that workspace, we have to work now. Okay, so first of all, we need to select the components from this library. So you can go to this library and first of all select registers. So you can type registers, you can select this 0.6 watt metal film and click on OK. Then also you can type your inductors, select inductors, fixed inductors, and the first value you can select the first option and click on OK. Next, you can select type tree. So it will directly give you your three-phase mains line generator. So directly it will give you this value. Okay. So we have all the components ready over here. Now we have to start making the circuit. Let me little bit make it a little bigger. Okay, fine. So first of all, we will make the three-phase. We will place the three-phase supply. So here is my three-phase supply. If I expand it, I can show it to you. This is how it looks like. So this is my three-phase supply. Okay. And now I will go back and select the resistor and RL load we have, right? We have to have a, star connected load. So what do we have is we have your R, you have your inductor over here. So let me place it over here somewhere. Okay. And let me place a resistor over here. Okay. They both will be in series. and then I can join them together. Okay, and then I can create a block by right clicking it. So I right click and click on copy block. So the block will be copied over here. Okay, so I am aligning itself. Okay, fine. So here I'll place one more, and downstairs I will place one more. Okay, so these are the blocks which I'm placing. This is my R and L. Okay, so as per our design, so we will consider the RLN value later. First of all, let us complete this. Okay, so let me join this together. All the register value, all the side. So basically, this will be the neutral. Okay, and the neutral is normally connected to the ground. So I'll take right click, go on place, and select ground. So I'll place the ground over here. Okay, and I join the connections with the ground. Okay, fine. So far so good. So next what we will do is, first of all, let us maximize this so that you have a better visibility. I hope that this is clear now. Okay. So next what we need to do is, we need to add a 2 wattmeters basically. Okay. I think I should make this distance a little bigger. So I will delete this. Okay. Let me delete these wires. Okay. So placement in the sense, the distance between them I should increase a little, and here also downstairs. Okay, now it's fine. Now I can connect them back. Okay, so these are the connections for the uh, star connected load, 2 wattmeter method measurement using star connected load. Now we have to connect the 2 wattmeters. So you can go to your instruments, and from here you can select 2 wattmeters. So the first one you can connect it over here, and the second one also you can connect it down. See to it that you reverse this polarity of the down wattmeter. I will tell you the reason a little later. Okay, so this is done, and I can connect their two of them together like this, and this is my B connection. So I'll connect it over here. Fine. So now also I have to connect, connect ammeter, AC ammeter. So AC ammeter is over here. Okay, and I also lastly want to connect the voltmeter. So I have my AC voltmeter connected over here. Okay, sorry for the disturbance. Now we will continue. So we will connect this milliammeter over here, from here to here, and here we have AC voltmeter, which connections goes here. Now let us connect the your three-phase supply properly. So this is my R phase. So this I will connect to this current coil. So see, in this wattmeter, you see this arrow. So these 2 points are current coil, and the plus and minus sign you see over here, this is the pressure or the voltage coil. Okay. So this connection I will do like this. Okay. And this current coil will be should be in series. So I have to connect it over here. Okay. Like this. Fine. And the lower wattmeter also we do have to do the connections. So over here we will connect it from here to here, and similarly the connections of the Y phase will be over here, and this current coil has to be in series. So here it is. So that's how the circuit will look like. You can see carefully. Okay, so these are my connections, and yeah, so I have to give this to ground. So I have to take another right click over here, go to place, and go to terminals and select the ground. So I have selected the ground. Fine. And now I have to set the values. So all the values we need to set. Okay. So let us wait momentarily. Okay, fine. So these are my two wattmeters. But as per the design values which we have taken over here, let's check. They are coming in kilowatts. We will come back to it. We'll come back to each and everything. They are in kilowatts. So what we need to do is, this is in VA. So we need to double click on it and change this display range to VA, kilowatts from VA. Similarly, do for a lower wattmeter. So you can change this to kilowatts. Okay. So this is my two wattmeters which are connected. This is my AC voltmeter and this is my AC ammeter. Okay. Now my connections are all are ready. Now we have to check out what are the values. And also I need to do one more thing. I need to right click and place a text. So I can place a text over here. I can call it measurement of power using 2 wattmeter method. And this is for 3-phase star connected load. Star connected load. Okay. So this is the heading. I can make it around 0.2. I can place it over here. Okay, that is not a problem. Okay, fine. Let me drag it properly over here. Okay. So now the circuit is ready. Now only thing is we need to decide the various values of R, L, the load, and the phase supply. So what we need to do is we need to go to OneNote PDF again, and we need to check out in the observation table what are the values which are given. Yeah. So in the observation table, the R value is 6.2. So we need to double click on this and select as 6.2 ohms. All of, okay. Just wait a sec. So we need to double click on this and select it as 6.2. Okay, I think the label is getting selected. We need to double click on this. Just a minute. We need to right click on this, go to edit properties, and from here you select change the value. Okay, so from here you change the value 6.2 and click on OK. Similarly, you have to do it for others. Right click on this register, edit properties, and from here you can select 6.2 ohms. Okay, that's the conditions, that's the values we have given. And okay, so I'll right click on this, go to edit properties, and again I'll select 6.2 ohms. Fine. And now the value of the inductor. Okay, so again I right click on this, go to edit properties, and I have to select the value as 0.0148. Okay, and click on OK. And similarly, the other values of the inductor, all the values should be same, 0.0148, and the last one also 0.0148. Okay, that's the part number. I did a mistake. Okay, I need to right click over here and go to edit properties again and select over here 0.0148 and click on OK. Fine. And now the phase which we want over here, it's around 440, right? But we need to select the RMS value. So over here we will select, we will double click on it. Okay, we have to right click on it basically. We have to right click on it, go to edit properties, and here we have amplitude, right? Frequency, let it be 50. Here we have to substitute amplitude as this is the phase voltage, so it will be 440 divided by root 2. So 440 divided by root 3 will come out to be 254. So we have to give over here 254 volts. Okay, and this is RMS value. So I repeat, the line voltage is 440. So your phase voltage will be 440 divided by root 3. So that will come out to be 254. That's why we have given here 254 volts and click on OK. Fine. So my everything is ready now. And once I simulate, I'll directly get the values. Okay. So let us start. I'll click on simulate. Okay. It's starting to give the values over here. And let me first expand and little bit, adjust this so that we can view it properly. Okay. So here we are getting the value of W1. This is W1, which is 5.66. First of all, you can take a print screen of this and attach it in your Google document. So this is my print screen, which I've taken. So once we have the print screen, we can analyze the results very, very carefully. So here it is. It's AC, so it slightly keep on changing. That's the realistic behavior. In actuality, also the AC keeps on changing slightly. So we have a line voltage, which is 443 volts. We have W1, which is the wattmeter one, which is giving the reading as 5.66 kilowatt. W2 is giving the reading 14.3, and the current over here is around 32.7 amperes AC current. Okay, so let's check this out. The calculations. I'll minimize this and I'll maximize this now. Okay, so here the observed values. Here we have to fill the table. So first of all, this is a star connected load. So we have been given VL as 440. So accordingly, we recalculate everything. And here also one more thing is given. We have a balance load. So balance load means RLL, all the, RLL we have same. We have around 6.2 ohms and 0.018 Henry. Okay. So we have to do the calculations and the observations for each case. So for first case, we have to calculate the current, W1, W2 observed and calculated values, and the total W and the power. Okay. So these things we have to do right now. Let us start. So first of all, we are getting the observed values. So we have written the observed values over here. VL was 440. IL was coming out to be in the star connected load 32.9. So that's what the readings which we are getting. Okay. Here it is changing continuously. Not a problem. So whatever values you are getting, you have to jot it down over here. Okay. So right now W1 is 5.65. W2 is 14.3. The voltage VL is 437 and the current is 32.8. So when I took this, these were the values which I was getting: 440, 32.9, 14.3 kilowatts W2, and W1 is 5.66 kilowatts. Okay. And total W is W1 plus W2, that will be 19.99, almost approximate to 20 kilowatts. And if you use this formula, root 3 VLIL cos phi, where cos phi is considered to be 0.8, that's what we have assumed, right? Yeah, cos phi is given as around 0.8. So we substitute over there. And finally, we'll calculate with observed values. IL and VL will multiply with root 3 and 0.8. You will get this 20.01 kilowatts. So this green color readings are my observed readings from the Proteus. Here we observed over here. Okay. Now, let us check by calculation what are the values. Okay. So actually, it was a problem statement given in a textbook. So we have been given a balanced three-phase load consisting of three coils. Now, three coils means each of resistance 4 ohms and inductance 0.02. Okay, these were some different values, but it was three coils consist of a resistance and an inductance of these values. We have taken a new values over here. So the values of a coil are 6.2 ohms with a inductance of 0.0148 Henry. Okay, so these were the values which we have taken, and yeah, they are connected to a 440 volts hertz three phase supply. So that's the line voltage we have been given. And similarly, the phase voltage will be VL divided by root 3. That will be 440 divided by root 3. That will be 254 volts. That's why we have given over here, uh, two, uh, you know, in the supply, three-phase supply we have given over here, phase voltage as 254. Okay, so that's the reason why we have given as 254. Now, the value of L and R is given as 0.0148 Henry and R is 6.2 ohms. Okay. Now, okay. So we need to calculate the total power and the readings of the 2 wattmeter connected to measure the power in the three-phase balance load. So that's what the the conditions were given. Okay. So the power factor is considered to be 0.8 lagging. So cos phi will be 0.8. So what will be cos inverse of 0.8? That will give it to you 36.86 degrees. Okay. Now we are concentrating on the calculation part only, right? So this is for calculation. So what will be XL given by? XL is 2 pi FL. L value is given as 0.0148. So XL will be 4.649 ohms. Okay. Now what will be your Z phase? So Z phase will be given by R plus JXL. So R value is 6.2, XL value is 649. So if you convert into polar coordinate, you will get a number 7.749, an angle of 36.86 degree. That's confirming our power factor as 0.8. Now, the phase current will be given by the phase voltage divided by the ZPH, that is the phase impedance. So 254 divided by 7.749, that will be leading to 32.778 amperes. So that's the value of IL we get, and VL is already 440. Now let's calculate the power. So W2 is given by the formula. Now this is already established in the theory, so I am not deriving it. So W2 will be given by VL IL cos of 30 degree minus phi, which is the power angle, which is your 36.86. So if you do the calculations, IL into VL into cos of 30 degrees minus 36.86, you will get a number as 14.32 kilowatts. So that's what I've written over here. 14.32 kilowatts is my W2, wattmeter 2 power. W1 is given by VL IL cos of 30 degrees plus phi. So over here we get the value as let me check it in the calculator once. 440 into 32.778 into cos of 30 plus 36.86. Okay, we are getting a number as 5.667. So that is 5.67 kilowatts. So indeed we are getting the values over here, and that value is coming out to be 5.67 kilowatts. Okay, and the total W value will be 19.99 kilowatts. So we can add these two, and this total power we can calculate over here. It will be root of 3 VL IL cos phi. So you take the calculated values of VL and IL and substitute it over here. You will get a value as 19.986 kilowatt. That is very, very close to 20 kilowatts. Okay. So this is how you perform the calculation and verify the values with the observed values. Okay. So one thing you need to remember is the load current and the line current and the phase current in a star connected load is same. So here the value is 32.778 amperes. So that's what we need to consider over here. Okay. So we have completed the star connected load connections, and in the observation table, we have to calculate. I have not written over here all the readings. You have to calculate all the readings for 440 volts line voltage, observed and calculated. Okay. Then you have to consider, all of you, I have not given the calculations. I have only given the calculations for 440 volts. Consider 330 volts line voltage and recalculate everything. So this will be your second reading. Every reading will have an observed value and a calculated value. For a second reading, you have to take it on your own. 330 volts line voltage and observed and calculated for a star connected load. So you please calculate this, all the values of IL, W1, W2, W and power, total power. So you see over here carefully in this previous observation table, by 2 wattmeter method, the power came out to be 19.99, and by actual calculations also the power was equal to 20 kilowatt. So it's very close. This is the method. This is the power by 2 wattmeter method, and this is the power by the formula. So both are exactly the same. Okay. So in practical, in reality, we measure the power like this by 2 wattmeter method. This is one of the technique. Where is the circuit diagram? Here it is. Okay. So now we have completed for the star connected load. We have to go for the delta connected load. So the delta connected load, the circuit diagram will look something like this. So this is the measurement of active power for delta connected load. As you can see, I have my 2 wattmeters connected over here to the R phase, Y phase, and V phase. So this is my delta connected load. I have the three, we have a coil basically. So three coils of impedance Z1, Z2, and Z3. They all are same. So we will consider the similar values of R 6.2 and L as 0.0148 as previously. So let's start connecting the circuit as given over here in Proteus. So I'll keep this open for 3 seconds so that you can note it down. This is the diagram which we have. Okay. And now we have to make a delta connected load. Okay. So I will minimize this and I'll open this thing and I'll do the changes here only. Okay. So let me just adjust this. I'll close the simulation. I'll stop the simulation. Okay. And now I'll adjust this properly. Yeah. So what I need to do is I need to adjust this properly. So in here also I will be in the same circuit. I will make it as a delta connected load. So for this, what we need to do is we need to delete these wires. So I'll delete this wire. I delete everything over here. Delete this wire also, and delete this ground also. Okay, and let me delete these wires also. So I'm converting into a delta connected load from star. Okay, and now let me select this. Okay, so you need to right click. Okay, it's not getting selected properly. I will be right clicking it. Okay, wait a second. Okay, it's giving some problem. Okay, I have to connect both of them together. So actually my mouse is not working properly. So what I will do is I will delete this, not a problem. And I'll make a new, I'll add a new values. Okay. New inductor and a new capacitor. I'll delete this resistors. And now I have to make it as a delta connection, right? So I'll remove this wire also. And I can push this. Okay, everything I have to delete, I guess. So I will delete this also and I'll delete this also. Okay, so now we are ready. So what we will do is we will go to our components and here I will select quickly the values of the inductor over here and the resistor. Okay, I have placed it over here. Now next is I have to place it vertically over here, horizontally. So for this, I'll connect this and I use copy and I will place it over here. Another one I'll place it over here. And basically what I need to do is again I need to rotate it clockwise and I'll place it over here. Okay. And similarly, I will be doing the same for this. So I will connect later. First, let me just, okay, now it's working properly. Rotate clockwise and I place it over here. Okay. Actually, I have to rotate, not a problem. Yeah. So here I'll do the connections now. So these are my connections. Okay, I'll join them together. So this becomes my delta connected load. Fine. So now this will go over here Okay, and this current will be has to be connected in series. So I'll take a wire over here and connect it over here. Okay, so be very careful about the connection. This is my delta connected load, and this will complete the circuit by connecting this last wire over here. Okay, so my connection is complete, and this has become a three-phase delta connected load. So this is my three-phase delta connected load. Okay, now let me adjust this properly so that it fits the screen. Yeah, now I have to, okay, it's lost. Let me, yeah. So now I have to give the values of your all the inductors and the resistors. 0.0148. Okay, similarly over here I'll right click and quickly do it. 0.0148, and similarly the register values over here, I'll right click, edit properties, and go to and select it as 6.2 ohms. Similarly over here for remaining load, here it will be also 6.2 ohms, and this inductor value will be 0.0148, and click on OK. And this lastly the register value over here will be 6.2 ohms, and I click on OK. Okay, so all the values are here. Let me drag it a little bit this side so that it's visible clearly. Okay, so all the values are fixed. Now we have to just click on the, let me just click on the play button, and it will start giving the current values. Okay, so the AC current over here, the line current is 99 amperes. The voltage over here, the line voltage is 437 volts over here, and your W1 will give us 17 kilowatts. W2 is giving us 42.9. So immediately take the print screen. One more thing, one more thing I remember, while taking the print screen, please add your roll number and your name, please. So that is, without that, your conversions won't be approved. So please add your roll number. So this is my three-phase delta connected load. I have taken the print screen immediately. So you take the print screen in your assigned Google document. Okay, let me, yeah. So these are the values which I'm getting. Let us cross check these values. Okay, with our calculations. Okay, let me just open this. Open the calculation part directly. Okay, so over here the observed values which I got as are for the delta connected load will be, the line voltage will be 437. Yeah, it keeps on changing, doesn't matter. If line voltage will be 437, the current which I'm getting was 98.3. Here I'm getting 98.5. That doesn't matter. It will keep on fluctuating. And the W2, okay, see it has changed now again. It is AC voltage, it will keep on changing. And the W2 was 43 kilowatts. So here it is close to 43. So you will get, all of you all will get a different value. So here you see again it has come. Okay, it's slightly changing. So it's okay. Marginally everything will change. So you have to accordingly take at that instant of time. So that's why you take a print screen, you take those values. Okay. And this is close to 43 kilowatts. This is 16.9 kilowatts. And W will be W1 plus W2. That will be 59.9 kilowatts. And finally, the power you can measure using the formula square root of 3 VLIL cos phi, where cos phi is 0.8. And VLIL, you have just observed it. Okay, so these are the values which you get. Fine. So this is how you measure the power using 2 wattmeter method for a delta connected load. So here it is a delta connected load, as you can see clearly. Let me, okay, I should adjust this over here. So this is my delta connected load. So if you observe it carefully, this point is this point over here. Okay, this is Z2, this is Z1, and this is Z3. I hope that there won't be a confusion if you see them together clearly. Okay, so these are the connections. Okay, so these are my 2 wattmeters which are connected, and these are my connections actually. Again, I repeat, this is my Z1, this is my Z2, and this is my Z3. Okay, and these are my connections for my 2 wattmeter method for a 3-phase delta connected load. And observe readings are coming absolutely correctly. And now let's check the values by calculation. So for delta connected load, the line voltage and the phase voltage are same, that is 440 volts. And the phase current is given by the phase voltage divided by the impedance of the phase, which is 7.749. We have calculated it before. So 440 divided by 7.749 will give you 56.78 amperes. Okay, and the line current will be given by √3 of phase current, which will be √3 times 56.78, which will be 98.34. Okay, so that's what we have written over here, 98.34 amperes IL for delta connected. So there is an increase in the current. And similarly, W1 will be VL IL cos of 30 degrees plus phi. So you check all the calculations, you will get 17 kilowatts. So here W1 we are getting 17 kilowatts of and W2 will be VL IL cos of 30 degrees minus phi. So that will give us 42.959 kilowatts. So you can substitute the values of VL and IL and calculate this number. This number is 42.96. Okay, and the total power will be the total this thing will be W will be W1 plus W2, which will be 59.96 kilowatts. And if you calculate using the formula, you will get 59.956. So observed readings and calculated readings are coming very much accurate. So this entire video was concentrating on explaining you how to do the connections in the star and delta connected load using 2 wattmeter method, how to measure the power. And I've showed you all the calculations. The calculations were shown how these numbers, each and every number has come. Okay, and yeah, you all can have a look. I will keep this for 3 seconds. See, this is the overview of all the calculations for star connected, and this is the overview for all the calculations for delta connected load. And lastly, in this observation table, now concentrate on this observation table. So we have completed point number 1, observation number 2. The third one was considered 440 volts observed and calculated values for delta connected load. So these calculations were given to you, and you have to do it the same thing for delta connected load, but the line voltage will be 330 volts. I hope that this thing is clear. The observation table, the R, L, and cos phi are given fixed, and it is a balanced load. And you have the line voltage was given, and you have to connect IL. You have to calculate IL, W1, W2, total W, and power. Okay. So so all the calculation values also. So all the calculation you have to show it for 330 volts. Okay, because for 440 it's already given. And so you need not write for 440 volts any calculations. So calculations for it directly you can write those numbers. But for 330 volts for star connected load and delta connected load, you have to show all the calculations and upload it in the Google document, Google Doc. Okay, so that's how we have seen today how to measure the active power for a star connected load in case of a 3-phase supply, and for a delta connected load using a 2 wattmeter method. So I think that's it for today's lab. Next time we will start with another topic. So until then, have a good day and thank you.